Hey there, ladies and gentlemen, and people. Miss Borkin here. Just wanted to say hello and give you a little bit of background on waves. So our new unit is called The Work of Waves, and the assignment we did last was this one here. It was a brief introduction to waves. Just one-page reading, and then behind that were 6 questions. So if you haven't done that yet, I would recommend starting there because it does give you a good foundation for this unit. So work of waves. Well, what is the work that waves do? What are waves? Well, waves are one way that energy can transfer from one place to another. We know a lot of different ways, like, electricity can transfer energy from one place to another. That's one way. Another way that energy can move from one place to another is by a wave. These waves all have certain properties in common. They have an amplitude, wavelength, frequency, and speed. So these are things that all waves have. And all waves can undergo refraction, reflection, diffraction, and interference. So these this top part's like things they have in common. And then down here it's like types. So over here is the electromagnetic waves. These are the ones we're talking about with the reading we did last, and these are the ones we're starting with. So these are interesting waves because they do not need a medium, and they are always transverse. So what does that mean? They do not need a medium. So all these different types of waves, X-rays, radio waves, infrared radiation, microwaves, and visible light, all of these things can go from point A to point B, even in empty space. They don't need water to carry them. They don't need air. They don't need a solid, any type of medium. No solid, no liquid, no gas. Nothing needs to be in between point A to point B, and they can still move from point A to point B. So if this is the sun, and this is the earth, and that light travels from the sun to the earth 93 million miles through empty space. So all of these different waves can move from point A to point B without anything in between. The mechanical waves, these do need a medium, and they can be either transverse or longitudinal. They are things like sound. So if I make a sound, the only way that I'm going to hear it is if there's air to carry those vibrations to my ear. So if I'm screaming in space, nobody will hear me, right? Because there's no air to carry those vibrations. Air, like a water wave. A lot of people think of waves and they think of water waves. These are waves. They're mechanical waves. A rope, if you do this with a rope, you'll get like a big up and down wave. Earthquakes, tsunami waves, all these type of waves require a medium. They have to have some air, some water. Even a brick can carry, like if I tap on a brick, but somebody's ear is pressed against the brick, maybe further down, like on a brick wall, they're going to hear that sound, and it's going to be traveling through that medium, that brick. So you might be kind of asking yourself, well, who cares about waves? There's actually a lot of things that depend on waves. We're living in a modern society. The world is completely filled with wireless technology, as you know. We are in a situation today that our lives rely heavily on the work of waves. I've used multiple devices just today. Microwave, smartphone, all these things depend on waves. Some types of waves we literally use every day. There are some that are hazardous and can significantly affect our health. You should know about the electromagnetic spectrum to protect yourself from the harmful ones and to be aware of the role that they play in our society. Some people use them at work. A lot of people do. A meteorologist, somebody who studies the weather, will need to understand many of these types of waves. Oceanographers and climate scientists, seismologists, people who study earthquakes. Lots of medical examples. This is just one. Electronics engineers, people making appliances for our kitchens and our homes and the devices that we use so often. All of these require knowledge of the electromagnetic spectrum and waves, and so many more. And like we said, there's like a classification. Not all waves are exactly the same. There's some differences, and some of them, the ones we're starting with now, the electromagnetic spectrum, these are transverse. And they look like what you think of maybe when you think of a wave, kind of this up and down pattern. A longitudinal or a compression wave, this is how sound travels. So it vibrates, there's a compression, rarefaction, compression, rarefaction, just kind of compression, rarefaction, compression. Both do the same thing. They transfer energy. They just do it in different ways. So back to kind of where we were, the electromagnetic spectrum. So E for electro, M for magnetic, so a lot of people just say the EM spectrum. And it has these 7 different sections it's broken up into. You can see over here on the radio wave end, these are long wavelengths, low frequency, low energy. And by long wavelength, we mean like really long, like could be 100 meters, could be more, could be big. On the other extreme end is the gamma ray. These are the tiny, tiny wavelengths, so small they're like the, from one wave to the next wave could be like the distance of a nucleus of an atom, small. And these are real short wavelengths, very high frequency, very high energy. This is the danger zone, kind of down here, and we're kind of right in the middle where we see. And then these are the more, they're pretty harmless. So your assignment, what I'm going to ask you to do is choose one of these 7. We're not going to take the time to look at all 7 in depth, but I'd like you to at least look at one in depth. So choose radio waves, infrared, ultraviolet, visible, X-rays, microwaves, gamma rays, whichever one you want. And once you've chosen, you're going to answer a few questions about your wave based on this picture here, like where is it on the scale of the highest energy to the lowest energy, or is it somewhere in the middle? What's around your wave? So all the first questions just have to do with the wave that you chose and where it is on this chart, kind of demonstrating and showing that you know how to read this chart. One thing I also wanted to point out is kind of the word wavelength. It's literally the length between 2 waves, measuring from one point on one wave to that exact same point on the next. So this is a wavelength. And here are the questions I'd like you to answer. Then for part 2, kind of the same, except now you might head on out to Google a little bit more. I did put some websites here that I thought were pretty interesting to get you started, but you can use them or not. It's really up to you. But I want you to think about your wave. Where does it come from? What are some natural sources of this wave? Can humans make this wave? Have we figured out that technology yet? Like a radio wave, we can make those. Are there other types that we might be able to produce artificially? Features of the wave. What's its wavelength and frequency? Let's see. What are some dangers and risks associated with this wave? Or does the one you chose happen to be harmless? Although even some of the harmless ones under certain circumstances can be risky or dangerous. What are the benefits and uses associated with this wave? You'll probably find quite a few of these for all of them because there are a lot of things we do with these waves. And lastly, just to kind of get this, a lot of people are visual learners, so like, what are some images when you look at your wave that kind of show, oh, okay, I'm starting to understand how this wave thing is working, and here are some pictures that really help me understand that. Okay, and that's the last slide, and that will be the end of your work. Again, if you have questions, I'm in the Google Meet. Please stop by and ask. I just kind of sit there with the, little piece of tape right here, and the microphone muted because my household there's a lot of distraction going on here, but that's okay. When I hear somebody entered that room, I come over. So please enter any time, and I'd love to answer your questions. And in the meantime, take care, please. Be safe and healthy, and missing you guys. This has been, a bit longer than I thought it was going to be, so it kind of feels weird knowing that we're going to end our school year this way. But we're going to do the best we can, and some of you are actually doing really, really well with this remote learning. I'm just blown away at how well you're doing. So keep up that great work. And take care in the meantime.